All right, so you got down side, side, side congruency, or hopefully you have anyway. We're moving on in the different congruencies. You're going to learn two more today: side, angle, side, or SAS congruency, and hypotenuse leg congruency. Side, angle, side, and hypotenuse leg. The first one we're going to talk about is the side, angle, side. This is very, very similar to side, 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 except you throw an angle in. Now, if you look at the way the word is written, side, angle, side, you have two sides and an angle. That's called an included angle. And what it means by included is it's in between the two sides. So if we look at this picture with RST, UVW, we have a side congruent with another side, and a side congruent with a side, and then in between those two sides, we have the congruent angle. So we would go side, angle, side with side, angle, side. Because we have two sides congruent, RT, oops, they've already written that down. Because we have side RS congruent with UV, that's the side, angle R congruent with angle U, the angle, and then the second side, RT being congruent with UW, we have side, angle, side congruency. And before you can say that triangle RST is congruent with triangle UVW, you have to prove that they're congruent. And so far, you've only known side, side, side congruency. But what if we don't have this third side? But they do give you the angle. Well, now you can use side, angle, side congruency to say RST is congruent with UVW. We're going to write a proof to show you kind of how you can do this. Again, a two-column proof with our steps and our reasons. We're given this diagram right down here. And the first thing that we're given is that BC, right here, is congruent to DA, right here. We're also told that BC is parallel to DA. So what we're going to do is we're going to write down what we were given first, that BC is congruent to DA, and that BC is parallel to AD. And that's given. Well, again, you need to reach back into your memory bank dealing with Chapter 3 and parallel lines cut by a transversal. Hopefully one of the things that jumps out at you right away is alternate interior angles. Alternate interior angles in parallel lines are congruent, which means that angle BCA is congruent to angle DAC by the alternate interior angle congruency theorem. Remember that if you can't remember the name of the theorem, you can just say alternate interior angles are congruent with parallel lines. You just said the theorem. You don't have to say the theorem name. So there we have angles congruent. Now, the other thing I want you to see is that we've got this side. Both of these triangles share this side. Well, that side is CA. Both triangles, ABC and CDA, have side AC in them. I mean, they share it. That's how they're connected. I can say that CA is congruent to CA. But what property, I'll give you a hint and say it's a property, what property allows me to say that something is congruent to itself? This is called the reflexive property. And this is the property that we talked about at the end of last section, actually a couple sections ago, right here. The reflexive property allows you to say that something is congruent to itself. Well, you can see here why we're using it. Both of these triangles have this same side, so I can say that CA is congruent to CA. Well, I just proved, or I was given, that one side is congruent, I proved an angle congruent, and then I just proved a second side congruent. What do I have here? I have side angle side congruency. Now that I've proven that, or now that I have those three congruency statements, I can say triangle ABC is congruent to triangle CDA by side angle side congruency. And let me just go through my proof and highlight it for you. Here's my side congruency, here's my angle congruency, and here's my side congruency. Because of those three congruency statements, I can say side, angle, side. Notice how the angle is in between the two sides, by the way. You can't have the third side or the third angle, okay? Make sure the angle is in between the two sides. And then you have side angle side congruency. And you're done. You've proven that ABC is congruent to CDA. Done. Exclamation point. That's side angle side congruency. Now we can apply that to actually solve some stuff. Example 2 says, are the two triangles congruent? Explain your answer. We're given triangle EFG and triangle PQR. Triangle EFG and triangle PQR. Well, what is the first thing you notice about the two triangles? One thing you might notice is that triangle E and P are congruent. You might also notice that the sides are congruent. Now, we could say right away, because EF is congruent to PQ, EF and PQ are both 5, so they're congruent. We could say that FG is congruent to QR because they're both 4. FG is 4, our QR is 4. We could also say that GE is congruent to RP. GE is 3, RP is 3. Well, that's a side, that's a side, that's a side. That's side, side, side congruency. But we could also use side, angle, side congruency. We could say that EF is congruent to PQ, that angle E is congruent to angle P, and that EG is congruent to PR. Here we have side, angle, side. Either way, we can prove that the two triangles are congruent. When we're asked, are the two triangles congruent, it's yes. We proved it using side, 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 and side, angle, side. Now, you only need one. That's the nice thing. But when you have multiple ways to prove triangles are congruent, you have options. Let's say you weren't given any angle measures. Well, that allows you to use side, side, side. Well, what if you're given two sides with an angle? Well, side, side, or side, angle, side then. It gives you options to prove triangles are congruent. Now we move on to hypotenuse leg. Hypotenuse leg is the only one dealing with a right triangle. Make sure you write that down. Hypotenuse leg deals with a right triangle. And in hypotenuse leg, what it's saying is, if in a right triangle, if the hypotenuse, by the way, the hypotenuse is the side opposite the right angle. Maybe we should write that down. Hypotenuse equals side across from right angle. Maybe you should write that down too. In hypotenuse leg, if the hypotenuse of both triangles are congruent, and a leg and one of the legs, it doesn't matter which one, could be either or, and one of the legs are congruent, then the two triangles have to be congruent. And that's called hypotenuse leg. If the hypotenuse and one of the legs are congruent, make sure they're corresponding legs. You couldn't have one, the back of one and the base of the other, or the height of one and the base of the other. But if the hypotenuse and corresponding legs are congruent, then the triangles are congruent by hypotenuse leg. And this is just another way to prove triangles are congruent. This is one of the only ones that deals with a right triangle. You could use side angle side if you have a right triangle, but most of the time you would use hypotenuse leg. Let's look at an example. Determine if the two triangles are congruent by hypotenuse leg. We're given right away that WY is congruent to XZ. So we need to go through our diagram and make some congruency statements. That WY, it's right here, get my highlighter out, WY is congruent to XZ. We're also told that WZ is perpendicular to ZW, that's why we have the little 90-degree mark here, and that XY is perpendicular to ZW. Now what I need to do, I don't know if this will work or not, perfect. What I need to do is I need to pull these two triangles apart just so I can properly label them. Okay, so I have triangle WZY. So I started at the top and went to the right angle. When I label my other triangle, I'm going to do the exact same. Start at the top, go to the right angle. So we have triangle WZY and triangle XZY. Well, what do you notice about the two triangles? Yeah, they have a shared side. When I have them overlapping right here, you can't really tell that it's a shared side. But when we write their letters out, you can see that we have ZY and YZ. Well, I can say that ZY is congruent to YZ because they both share the same side. It's the exact same side. What allows me to say that ZY is congruent to YZ? That is called the symmetric property. A property that where I have something being symmetrical on both sides. A second ago, in example 1, we used the reflexive property, where something is congruent to itself. Here, we're using the symmetric property, saying that ZY is congruent to YZ. It's the same length. If I look here, ZY or YZ is still the same distance. Maybe it's 5. They're both 5, so I can say that 5 is congruent to 5, or that ZY is congruent to YZ. Well, if I pay very close attention, this YZ and XZ, I'm going to pull this out. What do you notice about XZ? It's called the what? The hypotenuse. So we have the hypotenuse of one being congruent to the hypotenuse of the other. Then I have a second leg congruent, and it's a right triangle. Well, for hypotenuse leg, I need a right triangle, which I have. I need the hypotenuse to be congruent, which I have right here. And then I need a second leg to be congruent, which I have right here. I can say now that WZY is congruent to XYZ by the hypotenuse leg congruency theorem. Look at what you have. Look at what information you're given. Here we're given a right triangle with the hypotenuses being congruent. Right away, I should be thinking hypotenuse leg congruency, not side angle side congruency. Or maybe I'm given a triangle with all 3 sides. Right away, I should be thinking side, side, side. Use what information you're given and then determine, okay, this is the congruency that will best fit me. There are 3 that you know so far. Side, 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 angle, side, and hypotenuse, leg. 3 that you should be able to use at your disposal. Just like when we dealt with parallel lines, we were given corresponding angles, alternate interior angles, alternate exterior angles. Went brain dead. Consecutive interior angles. And you've had to use those since you learned them. The same thing with these. You learned side, side, side last section, but that doesn't mean you're not going to use it tonight for your homework. You're learning side angle side and hypotenuse leg, but that doesn't mean you're not going to use it in tomorrow's section or the next section that we come across. Make sure that you are familiar with these three, because as we keep adding more, okay, as we keep adding more, you're still going to have to refer back to these three and use them. Let's take a look at your homework now.